Now let us see the balancing of primary forces in multi-cylinder inline engine. Before we study the balancing of primary forces of multi-cylinder inline engine, let us understand what are inline engines. So in all the automobiles we see inline engines. So what are inline engines? See, the cylinders are placed. For example, if this is the line of stroke, if this is the the crankshaft, the cylinders are placed in only one side of the the common crankshaft. If this is the common crankshaft, then these are the cylinders. Now these four cylinders are placed on any one side. It means here above the common crankshaft. So these type of engines are what are known as inline engines. Now here, because in case of inline engines, see, this can be considered because we are transferring the mass of the reciprocating parts into a crank pin, and we are assuming it as a single mass rotating in one plane. Now this can be considered as, so mass rotating in one plane, mass rotating in one plane, mass rotating in this plane, mass rotating in this plane. Now this can be assumed as several masses rotating in several planes. So this problem must be solved similar to the several masses rotating in several planes. So we will see how this type of problems will be solved a little later. Now so what are the conditions now? What are the conditions for the primary balancing of multi-cylinder inline engine? Now first of all, summation of all the primary forces must be equal to 0. That is, in other words, the primary force polygon must be closed. Secondly, summation of all the primary couple must be equal to 0. In other words, the primary couple polygon must be closed. Why we need to consider both primary forces and primary couple? Because you saw the diagram of the multi-cylinder inline engine. So one cylinder was here, second cylinder, third cylinder, fourth cylinder. So because of the different cylinders placed in different places, placed like this. So one of the forces acting in this plane, another force will be acting in this plane, the force will be acting in this plane. Because these forces are acting in different planes, they will also produce couple. All these masses are not acting in one plane, they are acting in several planes, so they will produce couples also. So in addition to the consideration of the primary forces, we need to consider the couples also. That means for the resultant primary force must be equal to 0. In other words, primary force polygon must be closed. Then resultant the primary couple must be equal to 0, or the couple polygon must be closed. Since the reciprocating mass is transferred to the crank pin, it is same as the rotating masses, as I told earlier, because the reciprocating mass is transferred to the crank pin. So now this can be considered as a mass rotating in one plane or in several planes. So this will be solved similar to the balancing of several masses rotating in different planes. Now, so as we already understood that closing side of the force polygon will give us unbalanced primary force, and similarly closing side of the primary couple polygon will give you the unbalanced primary couple. So next, in the next slide, we will see the balancing of secondary forces in case of multi-cylinder inline engine.